Bismillahirrahmanirrahim. Assalamu alaikum. Today the fourth lecture of DSP is about discrete Fourier transform and inverse discrete Fourier transform. So first of all is the discrete Fourier transform. Here we use the non-periodic signals in discrete Fourier transform, but the formula of discrete Fourier transform is x of k is equal to summation of x of n into e power minus 2 pi j k n over n, where the k ranges from 0 to n minus 1. Here we consider the periodic signals in DSP. We can see that the maximum frequency is pi and the minimum frequency is 0 in discrete Fourier transform. So at 0 the value is 1 and pi by 2 the value is j, at pi the value is minus 1 and at 3 pi by 2 the value is minus j. The coefficient of discrete Fourier transform is equal to 1 over t naught into integration x of t into e power minus j k omega naught t dt, where omega naught is equal to 2 pi by t. The ck is equal to 1 over n into summation of x of n e power minus j 2 pi k n over n. Here 1 over n is the constant scaling factor. We can remove it and cannot affect the whole coefficient of the discrete Fourier transform. So we can see here is the example of discrete Fourier transform. The signal is x of n is equals to 1, 3, 0 and 2. Here the k range from 0 to n minus 1, but n is equals to 4. So here we use the formula x of k is equals to e power minus j 2 pi k n over n. So the maximum frequency is the sampling, half of sampling frequency. The sample here, the sample is equals to 4, means n is equals to 4. So 4 divided by 2 is equals to 2. Now we put 0, 1, 2, 3 into the formula and get the values, like x of 0 is equals to 6, x of 1 is equals to 1 minus j, x of 2 is equals to 4. So we know that here the maximum frequency is at the value of x of 2. So x of 2 is equals to 4. So this is the maximum frequency. But the important thing is that before the maximum frequency the value is 1 minus j, but after the maximum frequency the value becomes 1 plus j, because it is conjugate of each other. At the end x of k is equal to 6, 1 minus j, 4 and 1 plus j. Now the inverse discrete Fourier transform. The formula for the inverse discrete Fourier transform is x of n is equal to 1 over n into summation k is equal to 0 for n minus 1 and into x of k e power j 2 pi k n over n. Here there is no negative sign at power of e. We have two signals, x1 of k and x2 of k. x1 of k considers that there is the lowest frequency discard, and in x2 of k highest frequency is discarded. Now find x of n for both the signals. When we use the formula of x of n in both the signals, we get x1 of n and x2 of n. Like x1 of n is equals to minus 0.5, 1.5, minus 1.5 and 0.5, and x2 of n is equals to 2, 2, 1 and 1. As we can see that x1 of n is this signal and x1 of n is this signal, and here is the smallest frequency discarded, so the transitions are more in this signal and less fluctuations. In case of x2 of n, highest frequency is discarded and the transitions are less, so the peaks reduced due to the removal of sine waves and the frequencies. Here is the second example of this inverse discrete Fourier transform. The second example, the signal is x of n. X of n is equals to 2, minus 4, 3, 1, minus 2, 0, 3 and 1. So the 2 is at 0 value, minus 4 is at 1 value, 3 at 2 value, 1 at 4 value, minus 2 at 5 value, 0 at 6 value and so on. So x of k is equals to summation of n is equals to 0 to n minus 1 into x of n into e power minus j 2 pi k n over n. Here the samples is equals to 8, so the k range from 0 to 7. When we put the values of 0 to 7 in this formula, we get the value of x of 0, x of 1, x of 2, x of 3 and up to so on at x of 7. So x of 0 is equals to 4, x of 1 is equals to 1.172 plus 2.82j, and x of 2 is equals to minus 6 plus 6j, x of 3 is equals to 8.82 plus 2.82j. As we know that the maximum frequency is half of the samples. So here samples are 8. So 8 divided by 2 is equals to 4. It means that the maximum frequency lies at the value of 2 of x, at the value of 4. So x of 4 is equals to 8. This is the maximum frequency. So the before values of maximum frequency, here we can see that 4, 1 plus 1.72 plus 2.82j and minus 6 plus 6j and 8.82 plus 2.82j. But after the maximum frequency, there are conjugates of the values that before the maximum frequency. So at finally x of k is equals to 0, 0, minus 6 plus 6j, 6.82 plus 2.82j, 8, 6.82 minus 2.82j, minus 6j and 0. So this is all about today's lecture. Thanks for watching. Allah Hafiz.